Good morning, everyone. Welcome to Guru Brahma classes for JEE and NEET. We are learning about purification and characterization of organic compounds. Today, in this session, we are going to learn about quantitative analysis of nitrogen. In the quantitative analysis of nitrogen, we have two methods. One is Dumas method, and that is a Geldal method. We are discussing about the Geldal method. Let's start the session. What is this? Geldal method. We are finding the percentage of nitrogen in the organic compound, right? The Geldal method is used to estimation of estimation of nitrogen in organic compound. That means finding percentage of nitrogen in organic compound. Okay. You can see the setup or apparatus involved in this Geldal method. First, what is done? So this is first step, and this will be the second step followed. In the first step, we have taken Geldal flask. Into this Geldal flask, what is taken? Organic compound. Organic compound with concentrated H2SO4 and K2SO4 along with K2SO4. Here is along with K2SO4 is also taken. So what is taken in Geldal flask? Organic compound, Geldal flask. Right. So Geldal flask, what is taken? Organic compound is taken along with concentrated H2SO. So in this, we are heating, boiling. You are heating it by Bunsen burner. In the presence of CuSO4 and K2SO4. If nitrogen is present in the organic compound, it is converted into ammonium sulfate. Refining this organic compound, when it is boiled with H2SO4, what happens? It is converted into ammonium sulfate. Where did this nitrogen come from? Nitrogen came from organic compound. If organic compound contains nitrogen, then it will be converted into ammonium sulfate. What is the purpose of this K2SO4 and CuSO4? The CuSO4 acts as catalyst. What is this? Catalyst. When you heat it, the H2SO4 vaporizes. To increase the boiling point of H2SO4, what is used? K2SO4. K2SO4 is used to increase the boiling point of H2SO4. Okay. So that is the purpose of CuSO4 and K2SO4. So in the first step, what you are doing? You are taking organic compound, you are heating with H2SO4 in the presence of CuSO4 and K2SO4. This first process is called as what? Digestion. Okay. What is that called as? Digestion. You can see here, heating in Geldal's flask. Okay. Next, after heating this, whatever the components here, what is formed? Ammonium sulfate is formed. What is formed? Ammonium sulfate. So this ammonium, see, contents of Geldal flask after digestion, along with NaOH, it is heated here. So now, after digestion process, you are taking that mixture in the Geldal flask and placing into this round bottom flask. Round bottom flask. Into this, what is added? NaOH is added, and again you are heating it. What you are doing? Heating. So when you heat it, what happens? This ammonium sulfate. What is that? Ammonium sulfate. On heating with the NaOH, what is formed? NH3 is released. What is formed? NH3 is released. See? NH3 is released. Ammonium sulfate, when it is boiled with the sodium hydroxide, what you are getting? NH3 plus Na2SO4 plus H2. So nitrogen, finally nitrogen present in the organic compound entered into ammonia, came out as ammonia. So now what is released here? Ammonia is released. This ammonia slowly moves in this direction here it comes and it is absorbed into what? An acid. Mostly used acid is H2SO. Ammonia released here is moving and it is absorbed into acid. Generally used acid is H2SO4. Its concentration is known, that is standard H2SO4. Its concentration is known, and you are taking a particular volume. What is that? You are using, you know the volume as well as volume VML, let us take. You know volume as well as the concentration. So released ammonia is absorbed into H2SO4, mostly used H2SO4. This H2SO4 is standard solution. Standard solution means its concentration is already known, and it is having particular ml. We know the volume as well as concentration of H2SO4. Into this ammonia is absorbed. Okay. So released ammonia is absorbed into what? H2SO4. If you balance this equation, 2NH3, what you get? So you will get ammonium sulfate actually. Ammonium sulfate. So this is base, acid base reaction occurs, and salt is okay. Now let us see what is the N factor of NH3. That is what we want. What is the N factor of NH3? NH3 here, let us take NH3. By using one pair of electrons, it is accepting H plus. So it is donating this pair of electrons to H plus. So it is converted into NH4 plus. So here N factor for NH3 is 1. In this reaction, when it is undergoing acid base reaction, the N factor is 1 for this reaction. Okay, what is the N factor for H2SO4? H2SO4 is converted into what? NH4 taken twice SO4. So 2 hydrogens are replaced. How many hydrogens are replaced? 2 hydrogens are replaced. So N factor for H2SO4 is 2. N factor for H2SO4 is 2. Now you have to know some more things here. More things. So let us discuss those things. You are dissolving ammonia in excess of H2SO4. Right? What is that? Ammonia is dissolved or passed into excess of acid, standard acid, taking H2SO4. So now you take H2SO4 here. What is that? H2SO. This is H2SO. So when what you are passing NH into this. Some NH3. So what is this? Excess H2SO4. Excess H2SO4. After passing NH3 into excess H2SO4, some H2SO4 will remain unreacted. This point is a very important. What is that? Some H2SO4 remain unreacted. Some H2SO4 remain unreacted. This unreacted H2SO4, how much it is? How much it is known by titrating with a standard solution of NaOH. Okay. Let us take here, what I am taking is the same unreacted H2SO4. Okay. You are passing what to burette, pipette, you can take pipette. You are passing what NaOH. What is here? NaOH, standard solution. Okay. So you can take this, and here is unreacted H2SO4 by passing this NaOH by titrating with NaOH, the amount of unreacted H2SO4 can be calculated. Okay. So first what you have done, you have passed the ammonia released into excess of H2SO4. Already I am mentioning that it is excess. Okay, so there will be excess. Right? Now what you are doing is, some H2SO4 is unreacted. The same vessel is titrated with the NaOH. By titrating with NaOH, how much H2SO4 is unreacted can be known. So this particular point is very much important. Based on this, we are asked several questions in competitive examinations. So let us understand it by an example also. You can understand it by an example. For example, okay. For example, let's take here. You have passed, here there are 15 milli equivalents of H2SO. Okay. Now you are passing how many milli equivalents of NH3? Let us take NH3. 5 milli equivalents. Now will all NH3 react with H2SO4? No. Some 10 milli equivalents of H2SO4 will remain unreacted, because 5 milli equivalents of NH3 will react with 5 milli equivalents of H2SO4. Okay. 5 milli equivalents of NH3 reacts with 5 milli equivalents of H2SO. How many milli equivalents of H2SO4 is unreacted? 10 milliequivalents of H2SO4 is unreacted with whom? NH3. How can you know that? This is known by titrating the solution with whom? NaOH, standard NaOH. In this way, we can find how much amount of unreacted H2SO4 is present in the solution. Why we have to find? Because we have taken excess. We do not know how much, how many milliequivalents of ammonia is reacting with H2SO4. To know that, we are titrating the unreacted H2SO4 with NaOH, and we are finding the unreacted H2SO4. If you calculate the unreacted H2SO4, we can calculate the reacted H2SO4 with NH3. Okay, so this is actually called as back titration. This procedure is called as what? Back titration. Okay, we will find while solving the problems, we will find how this procedure continues, right? So that is about. So overall, in Geldal method, what did you find? We have found that the nitrogen present in the organic compound is released as ammonia. This ammonia is passed into excess of H2SO4. How much ammonia is reacting with the H2SO4 can be calculated by titrating the unreacted H2SO4 with NaOH. Okay, so this is actual procedure that is happening in what? Geldal method. In Geldal method, right? Coming to how to derive the formula to calculate the percentage of nitrogen by Geldal method. So here what is that? NH3 is reacting with the H2SO4. Okay. So what is the product formed? NH4 taken twice, SO4 plus H2. So this we know. Okay. From the law of milliequivalents, when it is applied to reaction, we can say that milliequivalents of NH3, 1 milliequivalent will react with the 1 milliequivalents of H2SO4. We are relating these two. And we know that, we know a formula that normality is equal to number of equivalents by volume expressed in liters. Number of equivalents is equal to normality into volume in liters. Milliequivalents is equal to normality into volume expressed in milliliters. This we know. This formula we want. Okay. That means I can write normality into volume of NH3 is equal to normality into volume in ml of H2SO4. This. Now I am taking, let the milliequivalents of NH3 be X. Now we know that as in this reaction, N factor, what is N factor? N factor of NH3 is equal to 1 from this reaction. Before also we have discussed. Now I can write that N factor of NH3 is equal to 1. 1 normal NH3. What is the meaning of 1 normal NH3? 1 normal means 1 equivalent present in 1 liter of solution. Okay. So 1 equivalent is equal to 1 normal into 1 liter. Volume 1 liter. Right? How much? 1 liter. I can write it as 1 liter. Now 1 equivalent n factor is equal to n factor is equal to n factor is equal to 1. N factor is equal to 1. So 1 equivalent is equal to 17 grams. 1 equivalent is equal to 1 mole when n factor is equal to 1. So 17 grams is equal to normality into 1 liter, right? So 1 equivalent is equal to 17 grams. 1 milli equivalent is equal to 1 equivalent is equal to 17 grams. 1 milli equivalent is equal to how much? 17 by 1000. Is it correct? Okay. 1 equivalent is equal to 17 grams. 1 milli equivalent is equal to 17 by 1000 grams. Now we can apply this here. Let me apply here. Right? 1 equivalent of what I am speaking, NH3 is equal to 17 grams. 1 milli equivalent of NH3 will be equal to how much? 17 by 1000 grams. Okay. Now X milli equivalents will be equal to X milli equivalents is equal to 17 by 1000 into X. Okay. Right? So this is what X I have taken. So from this I can write X is equal to X milli equivalents. So X can be written as normality into volume in ml of this is equal to this, right? Of H2SO4. Now you understood? Okay. Now percentage of nitrogen. What will you calculate? Percentage of nitrogen is equal to weight of nitrogen by, okay, weight of nitrogen by weight of organic compound into 100. Okay. So here actually 17 we are all calculating for NH3. But we want only nitrogen. We want only nitrogen. So 17 grams of NH3 contain how many grams of nitrogen? How many grams of nitrogen? 14 grams of nitrogen. So we want only these 14 grams. We don't want 17 grams. We want only 14 grams. Right? So then instead of 17 I can write 14 because we want only nitrogen, right? So weight of nitrogen is this, you see, this one is weight of ammonia. In this weight of nitrogen will be 14 by 1000 into X, okay, into 100 by weight of organic compound. Right? Are you getting this? This point is important. Why did we write 14 by 1000 into X? This is weight of whom? Ammonia. But in that 17 grams of ammonia, only 14 grams of nitrogen is present. We are calculating the percentage of nitrogen, right? Calculating the percentage of nitrogen. So X can be written as 14 by 1000, right? 14 by 1000 into X. X is what here? X is equal to milli equivalents of NH3. That milli equivalents of NH3 is equal to milli equivalents of acid, no? So I can write milli equivalents of acid. Whatever the acid you take, H2SO4 by weight of organic compound into 100. That is equal to 14 by 1000. Milli equivalent means volume into, see, normality into volume. What is that? Normality into volume in ml by weight of organic compound. Weight is nothing but mass. So if you cancel these two, then what you get? 14 by 10 into normality into volume of ml of whom? Volume into normality of the acid. Weight of organic compound into 100. So this is the formula. Into 100 will not be there. Already 100 cancel now. So overall, finally, percentage of nitrogen can be calculated as percentage of nitrogen is equal to 1.4, 14 by 10 is 1.4 into N into V ml of acid reacted with NH3. Okay. Weight of organic. So this is the formula. So we derived the formula. If you go on deriving the formula, finally we will be able to remember the formula. That is the purpose of deriving the formula mainly. Deriving formula may not be used for calculation because in our examinations, whether it is the JEE mains or advanced, we will be asked questions based on the application of the formula. So, but once if you derive it, we will be knowing how it is being derived, how it is got. And another thing is that we will be able to remember the formula. Understood? Right? So, percentage of nitrogen can be calculated by the formula 1.4 into normality into volume in ml of the acid that has completely reacted with NH3. Milli equivalents of acid reacted with ammonia. Okay, by weight of the organic compound. So this is the formula. So we need to remember this formula, right? You see here, we have found the. So from first onwards, if you see in this method, nitrogen present in the organic compound is converted into ammonia. Nitrogen present in organic compound comes out as ammonia. A known mass of organic compound containing nitrogen is heated with concentrated sulfuric acid in the presence of K2SO4 and CSO4. Then nitrogen present in the compound is converted into ammonium sulfate. So this is the reaction. What is this? Ammonium sulfate. So first it is converted into ammonium sulfate. Then the resulting solution is heated, distilled with excess of sodium hydroxide so that ammonia gas is released. This ammonia evolved is absorbed in known but excess. Already we have discussed this. Excess volume of either HCl or H2SO4, mostly used is H2SO4. Then the acid left unreacted is estimated by whom? Titrating against standard solution of sodium hydroxide. So percentage of nitrogen can be calculated by the formula 14 by 1000 into V into N. Volume is in ml of acid reacted with ammonia by mass of the organic compound into 100. So this formula is important. So you can see volume of acid in ml neutralized by ammonia. Then is normality of the acid, right? Next, coming to this method is simpler and more convenient. It is mainly used to find the percentage of nitrogen present in foodstuffs, fertilizers, soil, and various agricultural products. So this point is also very important. This method is not applicable to the compounds. Nitro compounds, it is not applicable. Nitroso compounds, it is not applicable. Azo compounds, if you find this, Okay, diazonium compounds also it is not applicable because you are heating it. So diazonium compounds are not stable. Azoxy. So azo compound, what is that? N, what is present? N double bond N. Azo compounds. These are what azo compounds. Azoxy. Azoxy, you are finding nitrogen, oxygen, extra oxygen, azoxy compounds. So mostly used is nitro, azo, and nitrogen present in the ring. See, in pyridine, is nitrogen present in the ring or not? Yes, nitrogen is present in the ring. Right? In quinoline, nitrogen present in the ring or not? Yes, nitrogen is present in the ring. So in these compounds, these are also, there are organic compounds which contain these groups. In those organic compounds, we cannot estimate or you cannot find the percentage of nitrogen by Geldal method. Why you cannot find? Because when you are trying to calculate the amount of nitrogen present in these organic compounds, quantitatively the nitrogen is not converted into ammonium sulfate initially. See, because nitrogen present in these compounds is not quantitatively converted into ammonium sulfate. In these compounds, it is found that nitrogen is not converted into ammonium sulfate. In the first step, we have seen in Geldal method, when you are heating the organic compound with K2SO4 and CSO4, it is converted into ammonium sulfate. So in these compounds, it is found that nitrogen is not converted into ammonium sulfate. If it is not converted into ammonium sulfate, then how can you calculate by Geldal method? It's not possible. Okay. Here K2SO4 increases boiling point of H2SO4 and CuSO4 is acting as a catalyst. Okay. So formula and which compounds it's not being converted. These two things mainly. Okay. The remaining things you understood, I hope so. Okay. This is derivation of the formula. Let us see some PYQ on this Geldal method of JEE main. So it is asked in 2018. Which of the following compounds will be suitable for Geldal method for nitrogen estimation? Will be suitable. Normally we have seen if nitro group is present, it is not possible. If nitrogen is present in a ring, it is not possible. This is diazonium chloride. What is that? Diazonium chloride. So diazonium chloride N triple bond N plus Cl minus. So in Geldal method, you are heating it. Okay. So when you are heating, there is possibility for this nitrogen to escape because it is unstable on heating. So it releases nitrogen gas. Nitrogen gas is released. So nitrogen is escaping. So there is no possibility because nitrogen is not associated with the organic compound and it is not coming into ammonium sulfate. It is not converted into ammonium sulfate. It is released as nitrogen. So this is not possible here also. The only possibility is here. So and especially some compounds like nitro, nitroso, nitrogen present in the rings, and diazonium or azonium, azo compounds. In this, nitrogen present in the organic compound is not converted into ammonium sulfate. So the answer will be suitable for Geldal method especially. Okay. Next, coming to Geldal method cannot. What is that? Cannot be used to estimate nitrogen for which of the following compounds? When it is asked in 2020. Now only we have seen if it contains nitro group, it's not possible. So answer will be this. It is not containing nitro. Okay. So what is this? Aniline. Is there nitrogen as nitro, nitroso in the ring, diazonium? No. Associated with carbon, hydrogen, and nitrogen. Okay. So this the nitrogen is not present in the as nitroso, diazo in the ring. Here also it is not in the second option. In the third option also nitrogen is not associated with nitroso and in the ring and in diazo compound. So in all these 1, 2, 4, you can estimate nitrogen by Gell method, but in the third option, nitrobenzene. What is this? Nitrobenzene. You cannot estimate nitrogen by Gell method. Next, coming to the question asked in 2020. What is that question? The Gell method of nitrogen estimation fails. It's not possible. For which of the following reaction product? Okay, product you have to see. So option A, let us take in this, what is the product? So nitro group, when it is reacting reduction SN plus SnHCl, then what is product formed? It is reduced to NH3. So this product to estimate nitrogen by Gell method, is that possible? Yes. For this product, it is possible. It is not possible. Fails. B option, let us take. So CN, cyanide. So lithium aluminum hydride gives you, okay, what CH2 NH2. Now there is no nitroso, nitrogen is not in the ring, so it is also possible to estimate nitrogen from this compound. The third one is okay, CH2CN. When it is reacting with first step SnCl2 plus HCl, in the second step it is reacting with water, hydrolyzed. Then what you get? This compound is converted into, okay, CH2CHO plus nitrogen gas is released as ammonia. Okay. So in this product, is there nitrogen? No nitrogen. No nitrogen. So nitrogen is not present here. In this organic compound, this is organic compound. This is not. In this organic compound, is nitrogen present? No nitrogen. So this product of this third reaction does not contain nitrogen, so you cannot estimate nitrogen. You cannot estimate nitrogen. And in the fourth one, D, you see, NH2 is reacting with water, NaNO2 and HCl. Nearly at very low temperature, actually 0 to 5 degrees centigrade. Okay, then what you get? Diazonium salt we get. What? N plus triple bond N Cl. So this is what diazonium salt. It is unstable. That is the reason why we have mentioned the temperature. Diazonium salt. Okay, it is unstable. As it is unstable, it releases N2 gas. So in the product we don't have nitrogen. Nitrogen is released out as nitrogen gas. So when it is released out as nitrogen gas, in the Gell method, nitrogen present in this organic compound cannot be converted into ammonium sulfate. So there is no nitrogen. How can it be converted into ammonium sulfate? So here also it is not possible. So what is the answer? The fourth option will be the answer, C and D. Are you getting this? Okay. Next question asked in 2021. Nitrogen can be estimated by Gell method for which of the following compounds? In which of the following compounds? Normally we have seen this is diazonium salt. Okay, it's not possible here. Here it is not nitro, it is not nitroso, it is not diazo, nitrogen is not present in the ring. So you can estimate here. Here in the ring, so not possible. Here this is a nitro, it cannot be converted quantitatively into ammonium sulfate, so not possible. So the answer will be second. Okay. Next, in Jaldal method, for estimation of nitrogen, CuSO4 act as, already we have seen in the Jaldal flask, we heat organic compound with CuSO4 and K2SO4. CuSO4 act as catalyst. It is acting as a catalytic reagent. Next, in 2024 question is asked, what is that? Jaldal method is applicable to estimate nitrogen in pyridine. So pyridine structure, pyridine. If you see pyridine structure, you will find nitrogen in the ring. There is nitrogen. Nitrogen is present in the ring. When nitrogen is present in the ring, is it possible to estimate nitrogen? No, because nitrogen cannot be converted into ammonium sulfate. So this is wrong statement. The nitrogen present in pyridine can be converted into ammonium sulfate in Jaldal method. Can be converted. So cannot be converted. So this is also wrong. So both statement 1 and 2 are false. Okay. That is the answer. Let us see the next question. Asked in 2021, 0.8 grams of an organic compound was analyzed by Jaldal method for estimation of nitrogen. If percentage of nitrogen in the compound was found to be 42, then dash ml of 1m H2SO4 would have been neutralized. Okay, so let us see H2SO4. For H2SO4, what is N factor? N factor is equal to 2. Okay, in the reaction, already we have seen this reaction twice. NH3 react with H2SO4 to give you NH4 taken twice, SO4 plus NH4 taken twice. That's it. Okay, salt. Here H2SO4, 2 hydrogens are replaced with 2 ammonia. So what is N factor? N factor is equal to 2. And we know that normality is equal to molarity into N factor. That is equal to normality is equal to molarity given 1m. 1m into N factor 2. That is equal to what you get is 2. Normality is 2. And we know the formula to calculate the percentage of nitrogen. What is the formula? The formula is percentage of nitrogen in the organic compound is calculated by 1.4 into normality into volume of acid, right, reacted with ammonia or neutralized by ammonia by what? Weight of organic compound or mass of organic compound, right? So here percentage given as 42 percentage. 42 is equal to 1.4 into normality 2. We want to calculate volume by weight of organic compound is 0.8. So volume is equal to 42 into 0.8 by 1.4 into 2, right? So on calculating this, what do you get? So 2 0.4. So 42 into 0.4 by 1.4. 4 2 is 8. 4 4 16. So that means right, 16.8 by 1.4. How much you get? 12. Okay. So what is the answer? 12 ml. Understood? Let us move to the next question. See here, the question is asked. When is the question asked? 2024, very much recent examination. Following Zeldal method, 1 gram of organic compound released ammonia that neutralized exactly 10 ml of 2m H2SO. Okay. So acid taken is H2SO4. We know that N factor for H2SO4 is equal to 2, and normality of acid is equal to molarity into N factor, that is equal to molarity given 2 into N factor is equal to 2, so that is equal to 4 normality. And you are asked the percentage of nitrogen. So percentage of nitrogen is equal to 1.4 into normality into volume in ml of acid exactly reacted with the NH3 by mass of organic compound, that is equal to, okay, what do you get? 1.4 into normality 4 into volume of the acid 10 ml, okay, by 1, that is equal to 1.4 into 40, that is equal to 56. So 56%. 14 4 sir, 56, right? So what do you get answer? 56%. Understood? Next, next question. The question asked is in 2022, right? You see this question, what is that? A 0.166 grams of sample of an organic compound was digested with concentrated H2SO4 and then distilled with NaOH. This is all the procedure of Zeldal method. The ammonia gas evolved was passed through 50 ml of 0.5N H2SO4. Okay. So what is that? See now, ammonia is released. This ammonia is passed into what? Passed into H2SO4. What is the solution? H2SO4. So when ammonia is passed into H2SO4 solution, some ammonia reacted and some ammonia, that is some H2SO4 reacted with ammonia, some remained unreacted. These things already we have discussed. Okay. Here, how many milli-equivalents of the used acid required? 30 ml of 0.25N NaOH. Right? So now let us write the equation. NH3 plus H2SO4 gives rise to NH4 taken twice SO4. Okay. We know that milli-equivalents of NH3 is equal to milli-equivalents of H2SO4. What is the milli-equivalents of H2SO4 that reacted? Okay, so if you calculate the milli-equivalents of H2SO4, then we will be able to know the milli-equivalents of NH3. So how much H2SO4 has reacted with NH3 is calculated by titrating with NaOH. Okay, so what he has done that this is H2SO4 reacted with NH3. So now what he is doing, he is titrating with whom? NaOH. Titrate. So when it is, he is titrated, now NaOH plus H2SO4 gives rise to, right, Na2SO4 plus H2O. Okay, Na2SO4 plus 2H2O, you can balance it. Okay, doesn't matter. Now, I can write milli equivalents of NaOH is equal to milli equivalents of H2SO4. And you know the formula, milli equivalents is equal to normality into volume in milliliter. So how much acid is required? See, milli equivalents normality into volume in ml. Here normality is given as 0.25. So 0.25 into volume given as 30 ml. So 30 ml. So that is equal to. So 30 into 0.25 gives you 7.5 milli equivalents. Already it is mentioned that milli equivalents of NaOH is equal to milli equivalents of H2SO4. If milli equivalents of NaOH is 7.5, then this milli equivalents of H2SO4 will also be equal to how many? 7.5. So these 7.5 milli equivalents have reacted with the ammonia. But originally, how many milli equivalents of H2SO4 are taken? Here, initial milli equivalents of H2SO4 taken. How many milli equivalents? Milli equivalents formula, how much? Volume in ml into normality. Here given 50 ml. Right? So 50 ml into 0.5 normal, 0.5. Actually, 25 milli equivalents are taken in this container. Originally, 25 milli equivalents are taken in this container. 25 milli equivalents. But how many milli equivalents were reacted? How did you know that? By titrating with NaOH, we have known that only 7.5 milli equivalents has reacted with NH3. Okay, why we are calculating how many milli equivalents of acid has been reacted with NH3? Because that is used in the formula to calculate the percentage of nitrogen. Understood? So, percentage of nitrogen formula is from Jaldal method 1.4 into, okay, normality into volume of ml of acid reacted or neutralized with ammonia by mass of the organic compound. Mass of organic compound. This is the formula. So now we can put 1.4 into normality into volume, milli equivalents. So I can write it as directly 7.5 by mass of the organic compound is how much? 0.166. So 0.166. Okay. So then what do you get? Okay. What do you get? You will get percentage as 63%. You calculate that, you will get the percentage of nitrogen as 63. So understood? This is all with what? Jaldal method to estimate the percentage of nitrogen present in the organic compound. Hope so you understood. I detailedly explained the concept, the procedure, derived the formula, solved the questions of PYQ, of JEE mains. So everything is detailed explained here. So if you can follow the video properly, then you will be able to understand, you will be gaining the conceptual as well as application knowledge, and you will have a confidence to attempt the competitive examinations. Right? Thank you for watching. We shall meet in the next video with a new topic. Let's meet in the next lecture. Right.